All right, good morning, guys. Happy Wednesday. I wanted to review a little bit yesterday, a little bit of yesterday's work. Today we're going to do the same thing, but we're tacking on monthly. It's compounded monthly now. But we're taking the same approach. On Thursday, we're going to review. Friday, we're going to have a very short quiz. It's only going to be a couple questions, compounding monthly. So 2 compounding monthly, 5 or 6 compounding annually, and that's going to be all we have for Friday. Next week, we're going to move away from logs. So this is going to be our final adventure into logarithms. It's been a while, but it'll be sad to see it go. So just to review yesterday, I said I invest $1,000 into a bank account, gains 2% interest compounded annually. So this was total equals our principal times 1 plus r to the t. And I want to know how long will it take for my investment to turn into 5,000 so that I can buy 555 Nikola Tesla finger puppets on Amazon. So if I substitute these values in, I want $5,000. I put in 1,000 at a rate of 2%. I want to find the time there. So first thing we're going to do, just like yesterday, we divided off this principal amount. So I'm left with, so this is step 1. Step 2, I had 5 equals 1.02 to the t. And step 3, I want to solve for t in the exponent, so I need to write this in logarithmic form. So log, what's the base of my exponent? Here, the base is 1.02. So 1.02 of 5 is going to be equal to t. And then I can always go to Wolfram Alpha. So wolframalpha.com. Wolfram Alpha, and type in the words log base 1.02 of 5. And that will get me a decimal of 81.27. So t equals 81.27 years. All right, so it's going to take me quite some time. Probably not make it that long. But we can probably rest assured that I can at least get a few hundred Nikola Tesla finger puppets with my $1,000 stimulus check. So that's yesterday's work. Today we're just throwing in the compounded monthly part. So if you remember from our interest quiz, that was like February, early February, late January. We threw in this part. So we divided by 12. We multiplied by 12 because there are 12 months in a year. And that's a whole other story. The fact that we have 12 months instead of 10, and that October is the 10th month and not the 8th month, and December is the 12th month and not the 10th month. So Google that if you're feeling really bored. That's an interesting story. So what we're doing is we're dividing that rate by 12, and then we multiply t by 12. But we're going to take the same approach. So let's say I put $1 into a bank account. that earns 8% interest compounded monthly. And I want to know, how long is it going to take for that $1 to turn into $17 so that I can buy my parents Chick-fil-A for lunch? So this is a compound interest problem, and again, we're using that rate divided by 12 to the 12 times t. We substitute all those known values in. That's our first real step. And then, just like we saw before, we divide it off that principal. It's just that 1 goes away. 17 divided by 1 is 17. And then I simplified this, so this turned into 17 equals 1.0067 to the 12 times t. And then we write this as a logarithm. So that goes into our logarithmic form. So log base, the base of my exponent here, the base is 1.0067. Log base 1.0067 of 17 equals 12 times t. And our very last step here, we're going to divide by 12 to get t by itself. So what we could do is we could just type this into Wolfram Alpha, log base 1.0067 of 17, and we get a decimal of 424.28 equals 12t. And then we would just take that number divided by 12. So divide both sides by 12. We get t is 35.36 months. So 3 years, only 3 years. That's really not so bad. We're going to take the same process. I left us 3 problems down here. I'm going to do the first 2 kind of with you, and then I want you to pause the video and try that last one. So the total amount equals the principal times 1 plus r over 12 to the 12t, because there are 12 months in a year. And let's see, this is going to be, I took out $180,000. So that's going to have to be my principal. I took out $180,000 loan for literally no reason at all. This is my interest rate, compounded monthly, and this is the total amount that I want, because I want it. I want to know, when am I hitting that $300,000 mark? When should I really start considering giving this money back? Well, if I substitute in all known values, step 1, 300,000 equals 180,000 times 1 plus 0.035 over 12 to the 12t. So that's my first step. Step 2, let's divide that 180,000 from both sides, just to kind of clean things up a bit. So I should do this in purple. 1.67 equals, and I'm going to simplify this part here. this part I'm going to simplify. 1 point, and then 0.035 divided by 12. 0.0029 to the 12t. So this, I simplified that fraction, I got a decimal, and then I added it to 1. So let me highlight that in yellow just to show you what I'm talking about. This is the same as this. And let's do this in green. Step 3. I want to write this in logarithmic form. So log base 1.0029. This is the base of my log because it's the base of the exponent of 1.67 equals 12t. And then I can simplify this. I can type this into Wolfram Alpha. So log base 1.0029 of 1.67 and I would get 177.092 equals 12t. And I can divide by 12. And I can get my final answer of how many months this is going to take. So I'll divide that number, that 177.092 divided by 12, and I'll get 14.76 months. So a little over a year. All right, let's try this next one together. So step 1, we're going to identify what am I given here. This is my principal amount. I used my credit card to buy lunch for my niece and I. That cost me $12 initially. I got a rate of 3.5%, and I want to know how long will it take to reach my total amount of $20. So $20 equals my principal times 1 plus the rate, 0.035. Divided by 12 to the 12 times t, because it's compounded monthly here. So that's step 1. All right, now step 2, let's divide this by 12 on both sides to get rid of that principal amount. So 20 divided by 12 is 1.67. Wow, that's interesting. Didn't plan that one. Equals, and I'm going to simplify this again. I'll do the same thing. 1.0029 to the 12 times t. And now I need to write this in logarithmic form. So log base of my exponent, 0.0029 of 1.67 equals 12t. So I'm going to give myself a little bit more room there. So log base 1.0029 of 1.67 equals 12t. And if I simplify that left side, if I simplify this, I get, like we saw earlier, 177.092 equals 12t. And just like we saw earlier, when I divide by 12, I get t is 14.76. So I'd like you guys to try that last problem here. Pause the video and give that a shot. Then you can unpause and check it out. So principal, $4. I used my credit card to buy $4 in ice cream. So that's my principal. Rate is 11%, and I want the total of $25. So 25 equals 4, 1 plus 0.11 over 12 to the 12t. So let's do our first step here. Divide off that principal. So step 2. 6.25 equals 1 plus 0.11 over 12 is 0.0092. So if I just add that to 1, if I simplify this, 1.0092 to the 12t. Alright, and let's take our next step here. We want to write this in logarithmic form. So step 3 is going to be log base. And what's the base of this exponent here? The base is 1.0092 of 6.25 equals 12t. Okay, well, let's take our next step of typing this part into Wolfram Alpha. Log base 1.0092 of 6.25 of 6.25 equals 12t. So 200.11 equals 12t. And if I divide that by 12, I get 16.68 months.